there. These rocks actually contain little pockets of glass. So that the glass is actually melted rock, which basically captured some of the Mars atmosphere. So what happened was that at some point in the past, and we think maybe, a million years ago, up to maybe 20 million years ago for some of these Mars meteorites, there was a large impact on the surface of Mars, and it kicked out these crustal rocks from the surface. And in the process, it actually melted little pockets of the rock, which sucked up some of the Mars atmosphere at the time.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Julie Tomei, and I am joined by Dr. Elena Hyde.
Hey!
How you doing?
Oh, I'm just peachy, except for it won't stop snowing. So we haven't been able to open the telescope tonight, but other than that, we're doing great.
Yes, another one of those dragging on February storms. I'm totally over it. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Science for the People, and Quirks and Quarks. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT. York Universe production works in concert with our online public viewing program run by the Observatory team, and that runs between the hours of 9 and 10 local Toronto time. Head over to www.yorku.ca/science/observatory and follow the links to OPV for online public viewing and join in the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on socials. On Twitter, our handle is at York University, it is at York Observatory. On Instagram, you will find us at York U Observatory, and on Facebook at Allan I. Carswell OBS. All our programs are free, but if you would like to make a donation, see our website. That is, again, www.yorku.ca/science/observatory. And there are some buttons there for you to click on to make donations. We certainly appreciate those. We'll be monitoring the chat room for questions, content. You've already heard that the weather is blah tonight. It is a mess of grossness, snow. There's some freezing rain coming our way, I think. It's just a mess out there. So no fresh new images on the telescope. It'll be archival images, but there will be some images over on the OPV regardless. All right, Elena.
Yes,
how are
indeed.
You?
Yes, I know the students are out there searching for archival images, poking around, seeing what we can possibly show you that's not clouds. I remember saying on this show before, if you really want to get astronomers excited about clouds, they kind of need to be on another planet. Preferably Mars. Let's talk about Mars snow instead of Toronto snow. Immediately more interesting. And actually, it's somewhat appropriate, because if we didn't have giant gales of snow and ice completely obscuring our view. There is a major aurora watch for this area of Canada that's actually had people seeing beautiful, beautiful northern lights at quite southerly latitudes. And I am very, very frustrated because I still have not seen the aurora since moving to Canada.
Yeah.
So anyways, this snowstorm is designed to flummox us all. And if it wasn't there, we have Mars really close to the moon. We've got the Pleiades, and there might even be aurora up there that we just can't see. It's incredibly frustrating.
Insert the Simpsons gif of old man yells at cloud here.
Yes, or astronomer, I don't know, shakes their fist.
Yes, let us all shake our fists at the cloud.
Mm-hmm. And if we could get above them, this is additional support for potential lunar astronomy. No clouds up there, so if you did have your telescopes on the moon or on an asteroid or something, it would be a much better place to see all kinds of stuff. And actually, watching the aurora from the moon would be kind of cool.
That would be cool.
So, anyhow, doesn't solve our immediate problem, but lots and lots of interesting stuff happening. And I think we'll talk a little bit about, when we get to reminders, we'll talk a little bit more about some stuff we can look forward to if it does clear, which, I don't know, February, Toronto, I don't know, March is also probably not going to be great. But
they're not great, but I mean, maybe we can put in our requests now with the meteorology deities.
Yes. Pet your black cat and cross your fingers twice, turn around 3 times, and that's all you can do, really.
Is that the formula?
Yes, that's all you need. You need a black cat, and no, I mean, we are kidding. That will not work. You need a spacecraft. Which we do not have. So if anyone would like to send us into space, you can email us at yorq.ca. We'll be happy to take into consideration any spacecraft trips you might have planned.
Nice. Well, how about we jump into our first This Week in Astronomy and Space History, because it does have something to do with a cloud.
Yes, it does. We can segue with cloud into Large Magellanic Cloud. This Week in Space and Astronomy History, in 1987, there was a particularly spectacular event that you would not have wanted to be clouded out for. The 1987 supernova, or supernova 1987A, as it's called. It exploded in the Tarantula Nebula of the Large Magellanic Cloud. And if you're not quite sure where that is in the southern hemisphere. So Toronto would have still been out of luck, unfortunately. But it's quite a fun event in history that happened. It is so the supernova that was in 1987. I have to remember when and not to call it 1987A, but it was the closest supernova since the year 1604, and it was the brightest supernova as seen from Earth since telescopes were invented. So telescopes had been around for a couple hundred years by 1987. In some form or another. And this particular supernova was the first one that we could actually see close up, if you will. So it could be seen from the southern hemisphere. The Large and Small Magellanic Clouds are satellite galaxies of our own Milky Way galaxy. So our sun and all the other stars you see in the sky are part of the Milky Way galaxy. And that galaxy has satellite galaxies that sort of orbit around it. So you can think about it like, I don't know, a fried egg, and the Large and Small Magellanic Clouds would be like 2 hash brown patties sitting at the bottom. I'm making a terrible breakfast analogy. But anyways, they are in the southern hemisphere, and they are sort of at the edge of interacting with our own galaxy. And because they are satellite galaxies, they appear in the sky as kind of these very faint, hazy cloudy objects, and it's not immediately clear that they're made of stars unless you have binoculars or a telescope. So that's why they were actually called clouds. So this nearby dwarf galaxy, the Large Magellanic Cloud, had a supernova explosion in it. We saw it in 1987, but of course it occurred 160,000 years before that, because the speed of light took that long to get to us. So the southern hemisphere brightness peaked, I think, somewhere in May of 1987, but it was the first opportunity for modern astronomers to see a supernova up close. And ever since then, of course, we have seen other supernova after this, but I don't think there have been any that were this bright for us. Of course, supernovas are always very luminous, but there has to also be nearby for us to get a good show in the sky. That's why everyone was so excited about, what was it, Betelgeuse a couple years ago. But this is sort of the last nearby supernova, and now we know that a supernova is the death of a star, or the death of a massive star. And this particular supernova, 1987A, it can now be seen as a beautiful cloud of expanding gas, which has been watched since 1987 by astronomers, which is really, really fun, because we've actually been able to watch that expanding gas from the explosion sort of going out into space. And what we think now is this supernova appears to have been what's called a core collapse supernova. So as the star exploded, the core of the star collapses, and that sort of rebound off of that collapsing core causes this big explosion, which of course emits a lot of light and makes it a very luminous object, which is pretty fun to see in the sky. So they were surprised by this supernova. It was not entirely clear how stars would explode in supernova cases. This is massive stars much more massive than our own sun. Now we sort of expect now that it's blue stars are more likely to explode in these supernovas because they are more massive. At the time, they actually thought it would be a red supergiant for type 2 supernova and not a blue one. So they got a little bit of a sneak surprise from there. And given the size of the star, they thought, oh, well, it should be massive enough to form what's called a neutron star. Neutron stars are these super, super dense objects that are held together by degeneracy pressure, where literally the sort of, I like to describe it as the electrons and the protons being sort of crammed together into neutrons, into this super, super dense state. It's as dense as you can get without making a black hole. But even though this supernova was watched in 1987, and it's been watched all this time, to this day, I believe, it's still true, I haven't seen any evidence that they have ever found the neutron star left behind by this supernova. So there's still a mystery about it. Supernova in general are really, really fun to study because, of course, we are made of stardust, as to paraphrase Carl Sagan, of course. But when you think about carbon and iron and things that are made up help to make human bodies and all life on Earth, those atoms had to be created in stars, everything that's not hydrogen and helium. And if it's much heavier than carbon, so things like iron and gold and all kinds of useful stuff, silicon, those are actually created in more energetic reactions. So in particular, gold is made in supernova. So take that for what you will. And actually, you can get all kinds of extra stuff as well. So you kind of wonder how elements are formed if you, so stars can't actually fuse anything past iron. And this gets us everything else on the periodic table. I think barring a few things that have only been created in special laboratory experiments. So, but yeah, for all of these reasons, for creating elements, for figuring out how life could evolve, for triggering star formation in other systems out there in the galaxy, supernova are incredibly interesting, and this one back in 1987 was an absolute rock star. So I suppose I'll just say, cheers to the supernova 1987A for being awesome and for still being a really, really interesting mystery to study.
Nice. We have a Canadian connection and a York connection to the supernova. I don't know if you knew.
Excellent.
Yeah. So the discovery it was discovered, it was seen in two places within the same 24 hours. But one of those two places was in Chile.
In Las Campanas in Chile.
Yeah.
Ian Shelton?
Exactly. Ian Shelton, who is a Canadian astronomer. I don't know if you've had the pleasure of meeting Ian.
No, I have never met him, but I did know he was Canadian.
Yeah. So he I think he teaches at U of T. He's also very active with the David Dunlap Observatory. So anyone who has visited the David Dunlap Observatory has almost certainly met Ian. So he was working with a local Chilean telescope engineer called Oscar Duhalde. So they observed it in Chile, and also Albert Jones observed it in New Zealand. So those three folks are credited with the discovery. So that's our first Canadian connection. And the York connection is that, so when a supernova is first observed, it's very bright optically, and lots of optical observations are done. But it does start to fade after several months. That doesn't mean that we can't still observe it. And so lots of radio astronomy gets done on supernova remnants. And so Dr. Norbert Bartel at York has done lots of research on supernova 1987A.
Oh, that's wonderful. Yeah, I neglected to mention that, but the expanding gas after the supernova explosion is particularly good to view in radio wavelengths. So that's excellent. We should have him on at some point.
Yeah. I worked for Norbert, I think 3 summers while I was an undergrad. I was mostly working on gravity probe B stuff, but I did do like data reductions on one data set of SN 1987A data.
Very nice.
It's cool. Yeah.
It's very, very code intensive reducing radio data.
It's takes a while.
And there are really advanced scriptings for it now, especially in Python. But I have to say that it is one of the most coding intense wavelengths to process. But it's totally worth it because the images are beautiful. Of course, all false color, but lovely supernova remnant images coming out. Yeah, that's wonderful.
Back then they just looked like, relief maps.
Yes, and of course those would have been originally, and I guess they would have been tracing them, right? Because you would have been actually making the contours and then tracing them out.
This is going back 20 years. More than
I mean that's the first radio processing was substantially more difficult because they did not have beautiful libraries of Python routines to help them.
Hey, it helped me pay for stuff, so I'm not complaining.
Hey, whatever gets the coffee, right? Because that's.
It was certainly a more interesting summer job than like flipping burgers.
Oh yeah, well, and radio is so much fun as well. I hope that someday we can put a little radio antenna up on the observatory roof. We'd have a lot of background noise though.
Well, yeah.
I mean, not this program.
No.
So don't worry about astronomy.fm.
Seeing as we're internet based, yes.
Yes. So here's extra advertisement for your local internet-based radio program.
All right. So let's move to our next item. And this is on February 20th, 1965, and it was the end of the Ranger 8 mission with a planned crash into the surface of the moon. So Ranger 8 was a NASA lunar probe, and it was the second successful probe in the Ranger series. Ranger 7 was the first successful one. The mission goals were to obtain close-up images of the moon, and those images were then used to select landing sites for the Apollo missions and for scientific study. Ranger 8 wound up transmitting 7,137 images before that planned crash. It had 6 television cameras on board. 2 were full scan, read wide angle, and 4 were partial scan, that is a narrow angle. It launched on February 17th, and it reached the moon, as mentioned, on February 20th. Images were taken for about 23 minutes, and between the altitudes of 2,510 kilometers and 1.5 meters. And then they crashed it. It crashed into Mare Tranquillitatis, or the Sea of Tranquility, leaving a crater that was 13.5 meters wide, and that crater was later photographed by the Lunar Orbiter 4, which was a later mission. Again, one of these missions that was done in preparation for the Apollo missions.
Very nice.
Mm-hmm.
Well, and of course, crashing something into the Sea of Tranquility is a little bit of poetic justice.
I guess they hadn't quite developed the soft landing technology yet. Or, I don't know, maybe they had.
No, 1965? I mean, did they even have the balloons?
I don't know. And I should know, because I was just looking at all the lunar missions last week, but not closely enough to have Paul's encyclopedic knowledge of oh yes, and this was in this year and that was in that year. But it did give me the...
Remembering numbers is not a prerequisite to be on this.
All good.
We do the best we can, but I do recall, of course, that the early soft landing was just basically inflate it in a balloon and hope for the best, and so your landing ellipses were the area that they would try to aim for. Were huge, which made precision landing really, really difficult, because it was already very, very hard to get any kind of precision landing. And I don't recall reading of them ever successfully doing a balloon type of bounce landing on the moon. But I know they did it several times on Mars, because on Mars you had enough of an atmosphere to sort of slow down a little bit first. With a parachute and then bounce around.
Yeah, I know the USSR did manage some soft landings in the 60s.
Yeah.
But I don't think the Americans did till
yeah. And that's so soft. It would in this case be an actual controlled landing.
Yeah.
So that's the big goal for all space landings, is to actually have a controlled landing, like you now regularly see from the SpaceX rockets coming back to Earth, and actually control landing their second stages on those bases. What do they call them? Their little landing platforms out in the ocean. They all have really fun names.
They did have a controlled landing. I'm remembering now. It's coming back to me. But it was a later mission.
Yeah, there've been some really interesting ideas on how to get on and off of other planets, because the moon and Mars both have lower gravity than the Earth. So in theory, it's easier, but it's actually harder, because you have to get there first and you've used up all your fuel. So getting a rocket on and off of the moon, is still very much non-trivial, and landing without crashing, that's we had to specify, is it a crash that we meant to do, or is it a crash that we didn't mean to do?
Yeah. Well, I mean, for the purposes of this mission was just like, we need pictures to pick a landing spot. It was the surveyor missions that actually were like, okay, now we're going to prove that we can land on the moon, and we have to see how deep the regolith is to make sure that like it's not just like really fluffy dust all the way down. And so those were like 66 and 68.
Right.
Or between 66 and 68, there were a whole bunch of surveyor missions. And there's actually like one of the Apollo missions landed close enough to one of the surveyor missions that there's photos of one of the Apollo astronauts like, check me out with this other thing we sent here.
Yeah, and it's interesting how much we get with like the repeat in history between the older lunar landing explorations and the next generation with Artemis, because now, I mean, for long-term exploration of the moon, we still need new landers, which are under development. I believe I haven't seen that they finalized the actual design for the new generation of lunar landers, but they do actually have to have that capacity to land somewhat softly and to get back up off of the moon again. So everything old is new again, I suppose. Except for that one that crashed. We'll leave that one.
Yeah, I mean, we have the advantage of like knowing roughly how deep the regolith is and what like its characteristics and stuff. So at least we're not dealing with like those unknowns. But you still have to test the technology before you send people down there.
Yeah, and it's and our precision now is so much higher than it was in these early missions as well. The landing ellipses are much more precise. So I'm much happier with the safety of the landing sites, but the technology of the actual piece of equipment, it's like, if it was a car, I'm not sure I would buy it at the current stage, is all I'm saying.
Not an early adopter, are you?
No, I'm like, well, if this was a car, I'd want to wait until it had gone through the crash test with the dummies first.
This is fair. This is fair. I mean, that's basically what Artemis 1 was, right? Put the dummies on board.
Yes, and they did have the dummies on board. They didn't land any dummies though. They just flew them around.
Really?
They flew out to that high orbit past the moon, because the next step for the Artemis program is to fly by with humans, not to land.
Oh, right. Sorry, I thought you meant they didn't land them back on Earth. I was like, but how are they going to get this?
Oh, no. Yeah. It did. Artemis 1 was a success. Don't worry. It did splash down. It was all great. The dummies didn't find anything in danger. I think even their little stuffed animal came back fine. But the next Artemis step is to fly by. But they still haven't done any landing on the moon. Tests, because their moonlander is still in development. So I'm waiting for them to start blowing out their landing capability. 2026 is what they've said. They want that sustained landing capability in 2026, and I was like, well, wait a minute, what time is it? It's only 3 years away. That's so fast.
That is really fast.
So that's why I say I'm not sure I would buy that car just yet. But anyway,
I'm with you on that. All right, let's move on to a slightly newer model of space probe.
One that also doesn't have to land.
It's true.
So yeah, I'll take us to a slightly newer. We sort of went from the old moon to new moon Artemis chit chat. But speaking of newer things flying by, back in 2007 on February 28th, we had the New Horizons probe fly by Jupiter going towards Pluto. And this was pretty fun. So New Horizons, if you're not familiar with it, is and was an interplanetary space probe. It was launched about 17 years ago, so back in 2006. And it went past Jupiter on February 28th, 2007, at a distance of about 2.3 million kilometers or 1.4 million miles. So this flyby was in order to steal some acceleration by flying past Jupiter and stealing a little bit via gravity assist, which is increasing the New Horizons speed because, of course, it also had to get all the way out to Pluto. So the whole purpose of this was to get enough speed to where we would eventually be able to reach Pluto. So this would happen the flyby happened in 2007, February 28th. So that's our This Week in Space and Astronomy history. It also tested a whole bunch of the scientific capabilities. So they went ahead and said, hey, as long as we're flying by Jupiter and testing our capabilities, let's return some science data. So they actually managed to take some really nice data from the atmosphere of Jupiter, some of the moons, and do some measurements of the magnetosphere, which is sort of this cavity created in the solar wind by Jupiter's magnetic field, and sort of measuring that effect. So once it got past Jupiter, the space probe New Horizons was put in hibernation mode with its stolen velocity as it zipped past, and it then had to spend almost 7 years in hibernation. So there was a lot of very tense waiting for the crew involved in this, because this is you would have to have just nerves of absolute, I don't know, titanium or something, because you had from 2007 until December 6, 2014, it was off, floating through the icy regions of interplanetary space, out past Jupiter, accelerating out, hopefully in the right direction to hit Pluto eventually. And it did. So they actually turned it back on in December 6th, 2014, which was a huge sigh of relief. And if you caught any of the press releases from anyone who was involved with the mission, they always started with, it turned on, it's okay. And finally in 2015, it actually began its approach phase to Pluto, which was the first time we ever had a flyby of Pluto. So this was a amazing mission. So the boost from Jupiter for the Pluto encounter was sort of we're on our way to Pluto, the swing by success. We getting a little bit of extra data for Pluto and its moons was a nice bonus. And I think the acceleration that it stole from Jupiter would have made almost no difference to Jupiter, because Jupiter is so much more massive than this tiny little space probe. But it gained, I think, about 9,000 miles per hour. So at the end, it was going something like 52,000 miles per hour to cover that sort of, 500 million extra miles that it needed to go. And the tremendous, incredible distances out past Jupiter in our own solar system are something that is reliably very, very hard for us humans to imagine, because it is hugely vast, the amount of no things that are out there between Jupiter, Saturn, Uranus, Neptune, and there's so much nothing in between. It's very, very hard for us to picture, because we look for the things that are there, and then we sort of condense them in our mind. So it's sort of New Horizons, in a way, has a huge advantage over humans, because of course it can go to sleep for 7 years and then wake up and be okay. To this date, I don't think any cryogenics of humans have had anywhere near that level of success. So it's fortunate that we do have these space probes that can go out there. The first image of Pluto, of course, coming back. The first really high resolution image of Pluto coming back showed, of course, that beautiful sort of heart-shaped valley on its, or plateau, I should say, on its surface. And, as it was sort of coming in, we sort of gradually got to the point where we're like, okay, now we're as good as Hubble, now we're better than Hubble, and then we were seeing things that we had never seen before. So there were lots of other little fun things that it discovered around the way. There was an asteroid that came by early on in the mission. As I say, the Jovian moons were all imaged by, the Galilean moons, I should say, because we now know Jupiter has a lot of moons numerically.
So many moons.
So many moons. But all of the Galilean moons were imaged. And of course, the Pluto approach, it just gradually came into focus as we got closer and closer to Pluto and Charon. There were some extra nail-biting moments because there was a little bit of a software anomaly that happened early on.
Mm-hmm.
And in the end, great success. We got amazing data from Pluto showing its incredible cold, icy landscape. It is the cold and icy heart of Pluto. It's really truly and very impressive. And we got very good images of Charon, Nix, and Hydra. Slightly less good images of Styx and Kerberos, which are the satellites of Pluto. And of course, it got an extension. So it did have a mission extension through 2021 to explore Kuiper Belt objects. And I believe it's still been extended. So it is still technically running. We had a flyby of Arakoth, or as it's called in the astronomical libraries, 486958 Arakoth, which I don't know why we need to be quite that specific, but it's the one that looks like a duck. And this was a trans-Neptunian object out past Pluto. So they're still sort of thinking that they might be able to fly by suitable Kuiper Belt objects outside of Arakoth, but Arakoth was the last one, and they're sort of keeping its cameras open, watching it going out into space. But that assist from Jupiter certainly helped, because even with that, it still took an extra 7 years after to finally get out to Pluto. So large distances out there in the icy outer solar system.
Yeah, these are such long-term projects to work on.
Yeah.
I mean, I remember the launch. I was working at Science North at the time. I remember the Pluto flyby because I went to the event at York University, and like just in my own life, the amount of things that happened in those 9 years, right? And like, I was not involved with the project. I was just an interested observer. I can only imagine what it's like to, and that's just like launch to arriving at the target. That doesn't even think about, the years and years of like proposing the project, getting it funded, building it, getting it to launch. Like, this is decades on a single project.
Yeah. Well, I mean, and that's assuming you all go to time as well, because things get delayed, and just ask Artemis.
Yeah.
20, 30, 40, 50 years later, it finally goes out. And so a lot of times it gets to be really like, wow, is it gonna happen? You feel particularly sad for those ones those satellite projects that don't make it, because it's such an incredible investment, but it's so worth it, because this was the first images of Pluto that we've ever gotten that were high resolution, and then we learned so much. It's so worth it.
Yeah. So let's move to our last this week in history. So we are jumping to February 22nd, 1996, with the launch of STS-75. This was the 19th mission for Space Shuttle Columbia. The crew included 2 Italian astronauts, Maurizio Kelly and Umberto Guidoni, a Swiss astronaut, Claude Nicolier, and a Costa Rican astronaut, I can read, Franklin R. Chang Diaz. The main objective of the mission was to carry the Tethered Satellite System Reflight, or TSS-1R, into orbit and deploy it. They'd hoped to deploy the tether to a distance of 20.7 kilometers. Unfortunately, after 5 hours and 19 kilometers of tether were deployed, the tether snapped, producing many pieces of floating debris. And the satellite did remain in orbit over a number of weeks after that. The mission flew the United States Microgravity Payload, or USMP-3, to investigate material science and condensed matter physics as well. The experiments on board that module included the Advanced Automated Direction Solidification Furnace, the matériel pour l'étude des phénomènes intéressants, la solidification sur Terre et en orbite. Short form there is Mephisto. I'm glad to see that the French also do ridiculous backronyms. Space Acceleration Measurement Systems, or SAMS, the Orbital Acceleration Research Experiment, the Critical Fluid Light Scattering Experiment, or XENO, and the Isothermal Dendritic Growth Experiment, also known as IDGE. All in all, a fairly unremarkable mission. So why did I choose to cover this? I chose it because of the fake STS-75. So in 1989, a fictional document called NASA Document 12-571-3570 was published in a Usenet news group. And this document detailed the so-called mission STS-75, in which astronauts conducted experiments to determine which positions were most effective for sex in microgravity. NASA has had to debunk this hoax a number of times, most recently when an astronomer and scientific writer, Pierre Kohler, used it as a major source about sex experiments in space in his 2000 book, The Final Mission.
Oh, no.
And I just call that lazy research.
Is that even research?
Well, I mean, I can see like coming across a document and going like, because this is like 2000, that's when it was published. You're researching it in like the late 90s, maybe mid to late 90s, right? Like the internet wasn't what it was yet. So like, sure, it wasn't as easy to like go on Wikipedia and see that like, oh, the entire crew of this mission was male. This document is about male-female sex positions. Clearly this is a hoax. But like, hi, phone NASA.
Yeah, well, and they publish contact information on their website for multiple different things. So it's not that hard to reach out to like your NASA information officer and be like...
It's lazy research and it's lazy fact checking and like publishers going, ooh, this is salacious. Let's publish it.
Yeah, well, that's why I say, if you haven't checked the facts, I'm not sure we can call it research. But yes, poor NASA has to debunk this and the moon landing, not being a hoax. I think every other year or so.
The opposite ends of the spectrum. Yeah. Yes, this is a hoax. No, this one isn't.
we have evidence both ways of this. Like the documents, as you say, at a very light fact check, just who was on this mission. You'd think that would, and versus what the paper was claiming, in theory. I mean, eventually, if you have human cities on the moon, maybe there will be a legitimate research study over there. But I don't think we're looking at starting a city.
How do you set that up? I don't know. Just
I wouldn't personally.
The ethics review on that would take forever. All things considered.
All things considered. No, if we're going to set up anything on the moon, I want it to be my basketball team. Oh, that's what I'm going for. Basketball on the moon. That's
basketball. I'm all for it.
I know, right? I was like, I've always wanted to be good at basketball, and I've never been good at basketball, except for that one trick where you dribble it like behind your back. That's it. That's the only thing I'm good at in all of basketball.
That's impressive. All right, folks. If for some reason you're tuning in 45 minutes into the show, you're listening to York Universe. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can head over to www.yorku.ca/science/observatory for chat, questions, content. You are listening to myself, Judy Tomei, and Dr. Elena Hyde. And we have just wrapped up this week in history. We have a few conjunction notes. And Elena, I will let you go through that.
Yes, absolutely. Shall I do that now then?
Sure.
All right. So let's make sure. So we were talking earlier in the show about the terrible clouds overhead and how they keep dropping snow and ice and terrible things on us in Toronto. However, if it were clear tonight, we would be able to see the moon and Mars and all kinds of great stuff. And if we wait just a couple days until it's no longer February but March of 2023, if you can believe it, and I say that because I can barely believe it myself. If we go to March 1st in Toronto.
Tomorrow. No, that's Wednesday.
No, it's not tomorrow. It's Wednesday.
It's Wednesday.
It's definitely Wednesday.
We'll have not. I'm losing time as well.
We'll have not just Mars and the moon, but we'll have in a beautiful line. We'll have the moon. We'll have Mars, and just before sun sets completely, so I would say 6:30 or so, it's going to, 6 to 6:30, you're going to see very, very close to the horizon, following the sun down, two bright objects very, very close to each other in the sky. And this will be Jupiter and Venus. So this is the conjunction of Jupiter and Venus. They're going to be within half a degree of each other, both very bright objects. So it should be very spectacular. If your skies are clear at all, you should be able to see it. It's going to be, you've got basically two of the four brightest objects in the sky. So the moon and the sun are obviously brighter than pretty much anything else. But Venus and Jupiter are the next in line in terms of brightness for us. So if it's clear at all, it'll be very, very spectacular. And within a half degree means that they're sort of in that same size on the sky as the moon. So they might even, if it's a little hazy, they might even sort of smush together and look like one object. It's going to be very, very nice. So conjunctions are really fun to view. They are not totally unusual, but the one that's coming up is going to be bright and fun and fabulous. So 0.5 degrees away from each other in the sky. It's worth noting that this is a conjunction. So it means that Venus and Jupiter appear to be 0.5 degrees away from each other in the sky, but actually they are lined up just to have that illusion. So it's a little bit of an optical illusion with conjunction, because of course all these planets and Earth are actually going around the sun. So Venus is actually about 206 million kilometers away, and Jupiter 861 million kilometers. So they're vastly different distances, and they're on these nearly circular orbits, but Jupiter has actually come around and is coming back out of its being on that side of the sun, the other side of the sun, if that makes sense. So we're looking at the sun going down, and of course, we're watching from that angle. We can see Venus, which orbits inside to Earth, because it's going to be close to the sun, which is why we always see it near sunrise and sunset. And then on the other side of Venus, on the other side of its orbit, that's where Jupiter is appearing to line up for us. So this happens about once a year. You get some kind of cool conjunction. Venus and Jupiter are relatively common, but at very, very bright magnitudes, -2, -4, it's pretty spectacular. It's a very fun object to view. You don't even need binoculars. So if it's clear at all, I 1000% recommend it. And if it is clear at all, we will try to live stream it over on YouTube, which is where our OPV is running right now. If you want to tune in and see what they've got to show.
Nice.
So always recommend to go outside and look uppity. Just not tonight, because
you'll get snowflakes in your eyes.
You went in ice, and it's really cold.
Yeah, no, just don't do that tonight. But Wednesday, if it's clear.
Oh yeah, so it can snow all at once too tonight. As long as it clears up on Wednesday, I'll be happy.
Sure. You know what? I'm even going to look up the weather for Wednesday and see what.
Yeah, don't look.
Oh, really?
We're just gonna hope, and I'll find a black cat later and give it a pat.
Oh, yeah, that doesn't look great. I mean, tomorrow night looks ish.
It won't be bad tomorrow night. It just won't be
Thursday
quite.
Night looks just lovely.
Yeah, so it won't
Wednesday
be too bad
night,
tomorrow
yeah.
night. There'll be Venus and Jupiter will be reasonably close tomorrow night. So tomorrow night is, of course, February 28th. If you are looking after sunset, or just as the sun goes down, 6:30 p.m., you might see it tomorrow night. They aren't going to be at their closest approach, but they'll still be pretty close in the sky. So a little more than, so it's more like a degree rather than half a degree, and you should be able to see them as two bright objects just following the sun down as it goes. So if it is clear tomorrow, maybe just go out and have that early look, just in case Wednesday doesn't pan out.
All right. So, I mean, regardless, go outside, look up if it's clear. We're an astronomy show. Go outside and do some astronomy.
Oh, yeah, absolutely.
All right. So we're going to get in at least one news story.
I think we have to do
yeah.
Taryn, we have to do yours, right? Because
yes.
Okay.
Yeah. So the Canadian astronomy community has lost one of its giants, I would say. Canadian astronomer, author, lecturer, prominent advocate for all things astronomical, Terence Dickinson, died on February 1st at age 79. Dickinson became interested in astronomy when he saw a meteor as a child, and that just became a passion that stayed with him throughout his life. He wrote many books, won many awards, including the Order of Canada, which is the highest honor that a Canadian can be given, I guess, outside of, military honors. He worked as an astronomer at the McLaughlin Planetarium in Toronto in the 1960s. He became the executive editor of Astronomy magazine in the 1970s, in the early 1970s, and around the same time, he joined the education department at the Ontario Science Centre. He, as I mentioned, wrote many books, but probably his best known is Night Watch, which has become a standard guide for backyard astronomers. It was updated several times, reprinted several times over the past 20 years. It's on many bookshelves. I have a copy downstairs. He co-founded Sky News magazine in the 1990s. He helped establish the Lennox and Addington dark sky viewing area north of Napanee, Ontario. He was a regular guest on Quirks and Quarks in the 80s and 90s. He wrote an astronomy column in the Toronto Star from the early 80s to the mid-aughts. He delivered lectures. He provided numerous people with their starts in astronomy. And he has an asteroid 5272 is named Dickinson in his honor. That happened in 1994. A name that I've always associated with astronomy. I started off reading those columns in the Toronto Star, cut them out. I had a scrapbook full of them.
Wow.
Yeah, that was my highlight. It was I think it was the Saturday Star. Maybe it was the Sunday Star. It was one of the weekend ones. Back when they used to deliver papers to the house and stuff. I'd come down in the morning and grab the section of the paper that was in and flip to the back, flip to the science page, be like, this is my page. See you later, folks.
Yeah, and I can't tell you how much fun I've had thumbing through all the previous editions of Sky News that I have found up in the observatory since I came to Canada. It's just such a wonderful, wonderful history of astronomy in Canada. And I think I've basically got a copy of all of them, thanks to, of course, Paul Delaney leaving basically a set of the Sky Newses. I'll have to see exactly how far back they go, but we might even have some of the original ones from the 90s.
Yeah.
And it's such a wonderful astronomy resource, and even just being here a little while. It's kind of been, I was shocked even. So I was like, well, I haven't even been here that long. It's just like, wow. What an impact he's had.
Yes, absolutely. Huge impact. I have a full set of Sky News. In fact, I discovered Sky News maybe a year after it went into publication. And I actually bought all the back issues. I found them at F's in Science, which is another institute in Toronto that is no more. But they had all the back issues. So I was like, I want them all. I remember sitting in the back of my physics class, just like thumbing through the magazine before class started. Reading all his columns, and it was great. It was great to have, a Canadian astronomy magazine.
Yeah, well, it's worth remembering that a lot of this stuff is still around. It's the McLaughlin Planetarium, of course, is still the building is still there.
For now.
It's for now. I mean, maybe someday it will be a planetarium again.
Not if you believe what you read in the papers, but
oh no.
Yeah.
It's a planetarium for Toronto is just such a no-brainer. I would love to see that come back again. Maybe it could be named after him or something. Start a petition, Canadian petition for.
Right. I will suggest it to the folks at Space Place Canada.
I would sign that.
Yeah.
Oh yeah.
I would too.
I would put up an extra little ad on our observatory website. I think it would be a great idea, and you all can comment. I suppose comment on social media if you would love to see this happen, like we would. Planetarium back in Toronto for Terrence Dickinson. I think that would be really fun.
Yeah.
And we haven't even hardly talked about the the dark sky viewing activities that he was involved in, because dark sky astronomy is such a huge area, now, and we know so much more about how to mitigate light pollution. But he was starting up dark sky areas, quite a while ago in is it Toronto or the whole Ontario area? Because he did at least two that I heard about.
I'm not sure. I'd have to look it up. I know for sure the Lennox and Addington dark sky viewing area, because that's near where he lived. And yeah, I'd have to look up, but it wouldn't surprise me if he was involved in more than one. Because yeah, I mean, if you're gonna do some dark sky observing, you need some dark skies. And I remember Torrance Barrens was established
If you enjoy Astronomy FM radio, please let us
when I
know
was still
with a
in
small
university,
donation.
and now
We do rely on your support, and it's true.
there
Every little
there are
bit
dark
counts.
sky sites, tons of them, which is fantastic.
Yeah,
You
well,
are
and
listening
just the
to a universe
you know,
of
as
possibilities.
somebody who is also
This is
passionate
Astronomy
about
FM.
you know, dark sky viewing, it's so important to be able to get those dark sky views. You know, of course, that's one of the reasons why we have our astronomer in residence program with the Killarney Provincial Park. But it would be really nice to see, like, to some extent, some of that same, you know, dark sky preserves come back into, you know, the Toronto area of Ontario, so that we could have dark sky, you know, parks.
Right.
Anyways.
Well, we'll have to cut it off there.
Yes.
But thank you for listening. This is a Science Night in Canada. So stay tuned. Good night.
The police have been running up and down the street and telling us that we need to get out.